Have you ever wondered how computers recognize patterns, how they can tell the difference between a series of 1S and 0S, and use that data to make sense of the world around them? Well, the answer lies in networks, specifically Hamming networks. Named after Richard Hamming, a Hamming network is a type of artificial neural network designed specifically for binary data. It's a tool that computers use to classify and recognize patterns. But how does it work? Imagine a series of binary vectors, sequences of 1S and 0S, streaming into the network. These vectors must be of a fixed length, with each element corresponding to a specific feature or attribute. These are the inputs to the Hamming network. These inputs don't just pass through the network untouched. They interact with what are known as weighted connections, links between the input and output neurons. During the learning phase, these weights are adjusted, helping the network to recognize specific patterns. At the heart of the Hamming network is the concept of Hamming distance. This is a measure of how many positions differ between two binary vectors. Essentially, the network aims to minimize this distance between the input pattern and the weight vectors associated with each output neuron. Once the data has been processed, the output neuron with the smallest Hamming distance to the input pattern is activated. The rest remain inactive. This winner-takes-all approach is what allows the network to recognize and classify patterns. But it's not a one-and-done process. The network learns adjusting the weights based on the input patterns and the desired output. The goal is to train the network to respond correctly to specific input patterns. Hamming networks have found uses in a variety of applications, from error detection and correction to data compression and pattern recognition tasks where binary patterns need to be classified. But as with all things in the field of artificial intelligence, things are constantly evolving. While Hamming networks have been historically used, more advanced neural network architectures, such as deep neural networks, have gained prominence in recent years. These advanced networks can handle more complex data and tasks, pushing the boundaries of what is possible in the world of pattern recognition. So, the next time you marvel at how a computer can recognize patterns, remember the humble Hamming network and the key role it plays in the world of artificial intelligence.